All right, now let's have a look at this. Disconnected graph has 6 vertices. All right, so I know with the disconnected graph there's actually one vertex which is not connected to anything, correct? Now, the other thing that I will start to do is highlight things like 2 vertices of degrees 2, and then 3 vertices of degree 1, 3, and 4 respectively. You must be able to draw this graph, all right? It's quite typical of first part of the question, I would say. So what I would do is start off with 6. 1, 2, 3, 4, 5. I'll leave the 6 out because I know the 6 is not. You don't need to connect it to anything. So if I've got 1 with 4, I'll start with that. 1, 2, 3, 4. All right, I've done that. Now, I know that there's 3 vertices of degree 1, 2 vertices of degree 2, 3 vertices of degree 1. What do I do? How could I do that? What does degree 1 mean? So that's only 1. All right, 3 vertices of degree 1, 3, and 4 respectively. So there's 1 vertex with degree 1. So 1 vertex with degree 1, you don't have to connect to anything, right? So if I leave that here, that's 1 done. Yeah? All right, let's have a look at the other one. So if I go from here, I want to connect 3. 1 more, and then 1 more. So that's 1, 2, 3. That's 1, 2. That's 1, 2. Agree? Yeah? Yeah. Do you agree with what I've done there? Everyone? Yeah? I've got 1, 2, 3, 1 of that. So I've done that as well. And now I've got 4. 1, 2, 3, 4. What am I missing? I'm actually not missing anything because it's 2 vertices of degree of 2. That's 2 and 2. That's it. This is how you deduce it, how you draw it. There are many ways of doing it. This is one of the ways. All right? The other way that I've done it before was something like this. Which looks like this. 1, 1, 2, 3, 4 connected, and I've got 1 crossover, and then 1 connected that way. So that's fine as well. So I've got 6 vertices. It looks something like this. All right? So you are allowed to have some different sort of set of drawing. You don't actually have to follow what I do exactly, as long as you know that there's 1 that's connected. Everyone happy with that? I know some of you were not here yesterday, so you've got to just watch the video from yesterday and work out. All right, let's go on. Move on to the next one. More definition, more memory work. You must always remember what I've taught you. All right. All right. Next thing, what we're doing is types of graph. Again, it's a lot of thinking and remembering. Now, you should be able to identify the various types of graph and be able to classify the graph. All right. Recall graph. You've got vertices, you've got edges, and you've got faces. All right. So this one actually summarizes quite a lot. Here, these are multiple edges because there's 2 going into two vertices connected by multiple edges. All right. There's a loop here. There's a vertex. That's called the edge. All right. And there's isolated vertex. Now, 1. This is a weighted graph. It will be used quite a lot later in probably next week. You will think about distance. You could think about cost. So looking at something like this, a weighted graph, you would have to work out what is the shortest distance, or what is the minimum cost, or what is the minimum time, that sort of thing. All right, you've got probably distance travel. You've got to think about probably the time it takes from one place to the other, and you've got to be able to analyze the graph. Analyzing the graph, you have all the graphs will be given, should be weighted graph. All right? Now, a null graph. A null graph has no edges, and it's made up of only vertices. And a trivial graph. A trivial graph is a null graph with only one vertex. All right. To be honest, I need to show you this too, but I've never seen that coming out in an exam before. All right. It's part of the thing that you need to know. So you should know a null graph without edges, only vertices, and trivial graph, only one vertex. Simple graph. Now, this has come up quite a lot, and this definition has been tested quite a bit. So can you please think about what a simple graph is? It's one that's undirected and one weighted, no loops and no multiple edges. All right? So please highlight the definition of a simple graph. They test simple graph by asking you to draw one. All right? Generally, I've seen questions on simple graph. So make sure that you know simple graph is one which is undirected. No direction, there's no weight, and there's no loops, no multiple edges. You can see that the first one, A, B, C, D. Everyone, there's no multiple edges because there are no two vertices that's connected by multiple edges. All right? Whereas graph number 2 is not a simple graph because A to C, there are two edges. All right? And then the third one is not a simple graph because B has a loop. Now, there is also simple directed graph or simple weighted graph. Those are directed graphs and weighted graphs that have no loops or no multiple edges. Okay? Seen a couple of questions, about 3 questions in the last few years in the exam in ways asking you to draw a simple graph from given description. So make sure that you know a simple graph. All right? Connected graph. Now, you can see the difference between a connected graph and disconnected graph. A connected graph, everything is connected, whereas disconnected graph, there could be an isolated edge, or a part of the graph is not connected. All right? The important thing is the word bridge. Again, bridge has come out in the exam quite a few times. So if there's a single edge, if this edge is taken away, it becomes 2 or more separate graphs. That is called a bridge. All right? They have tested on the definition of a bridge. They have tested on asking you how to identify bridges. So make sure that you know a bridge is an edge when it's removed. It causes 2 graphs. We call this a subgraph. All right? I'll talk about subgraph a little bit later. So this is a subgraph of that. So is this. All right? You just split it into 2 different parts. All right? So remember the word bridge. Now, from here, can you identify any bridges? Which one do you think is a bridge? Or which one, are there more than one bridges? Do you think there are more than one bridges in this case? All right. So if I do it this way, if A5 is actually a bridge, because if you remove A5, you've got 2 separate subgraphs. So here it became A1, A2, A3, A4 connected together, but that's not connected. A5 is gone. Or if I take out A6, that's an isolated vertex. So either this or that could be a bridge. I've seen questions asking you to redraw a graph without a bridge. All right? Any question before I move on? 2 things that you really need to know from here. Now, regular graph. Regular graph is one in which all its vertices have the same degree. So if you look at E, G, and F, this is a regular graph as all the vertices have a degree of 2. The next one, all of them has a degree of 3, and they are also, that is also a regular graph. Haven't seen a lot of question on this, but it's good to know what a regular graph is. All right. I'll move on. Complete graph is another one that you must know. Practically, I think in the exam, in the test, in ways, it's come up. Practically, I have quite a few years. All right. So simple graph in which every vertex is connected to every other vertex by a single edge, not multiple edges. All right, I call complete graphs. A complete graph with n vertices is sometimes sometimes denoted as Kn. That is quite a common one that is used quite a lot in the exam. All right, so there will be a question say that Kn is something. All right, draw it or analyze it. So for example, I've got K2 there because that's 2 vertices and 1 single edge. K3, 3 vertices. K4, you've got 4 vertices. All right. Now the next one is not in your formula sheet and it's worthwhile knowing. A complete graph with n vertices has n into n minus 1 divided by 2 edges. That is worthwhile knowing. Again, it has come out in the exam before. And I've drawn the various graph up to K6. See, even with K4, you might be able to redraw it. You can redraw it as this. K4, 1, 2, 3, 4, connected that way, and then it's connected this way. There's also K4. All right, so there are questions asking you. We will talk about why we need to convert this to that next week. All right, so that is important. Complete graph is important, and know the definition of Kn. Subgraph. A subgraph is a graph that is part of another graph with no new vertices or edges. Again, important definition, being out in the exam a few times. All right, so every graph is a subgraph of itself. And you can see that this is the original graph. And if I take away AD, this is a subgraph. All right, if I take away AB, BC, and BE, there's another subgraph. If I take away everything, this is another subgraph. All right, graph 1, 2, and 3 are all subgraphs of the original graph. Okay, now note that graph 3 is also a subgraph of graph 2. So it's part of the graph, and you just need to be able to redraw it. All right, that's all I have for you today. So please make sure that you know the things I've said. Subgraph is important. Complete graph is important. Bridges are important. And regular graph. All right, I'm going to stop here, and you've got enough work to do.